Today we're going to talk about rational numbers today. Okay, these are rational numbers here, but there are also other sets of numbers. Okay, we have natural numbers. That's what you first learned. Okay, 1, 2, 3, 4, 5. Whole numbers, you add 0 to it. Integers, we've been talking about all year. Okay, they're whole numbers, they're natural numbers with the negative version of those. So -3, -2, -1, -100. Okay, but they do not have fractions. Integers don't have fractions or decimals. Okay, they're pretty much whole numbers with negatives. Okay, rational numbers, you need to write down the definition of rational number. It's any number that can be written as a fraction. All right, so these are examples of rational numbers. I have 0.87, I can write that as a fraction. I'd write it like this, 87 over 100. 4/5 is already a fraction. -2 and 56 repeating, we can write that as a fraction. Okay, repeating numbers can be written as a fraction. And then -23, I can write that as -23 over 1, so I can make that a fraction. So every one of these can be written as fractions, so they're included when we talk about rational numbers. All right, write these down. All right, write each rational number as a fraction. -15, I can write that as -15 over 1. All right, 6 and 1/6. Since it's already a fraction, they must be asking for an improper fraction. So what I do is I take the whole number times the denominator and then add the numerator. 6 times 6 is 36. 36 plus 1 is 37. I keep my denominator at 6. 4 2/3. 4 times 3 is 12. 12 plus 2 is 14 over 3. All right, write this down. Write the decimal as a fraction in the simplest form. Okay, if you see something like this, what we do is we count how many decimal places it is. What decimal place is the farthest number? So 4, what decimal place is it in right there? No. It's in the hundredths. 6 is in the tenths, right? So 4 is in the hundredths. Okay? Once we know what decimal place the farthest one is, we just write this number over 100 since it's in the hundredths decimal place. That's all we do. Okay, if it was 0.5, I would write it in the over 10, right? Okay, now don't forget you have to reduce. 64 over 100. Okay, if they're both even numbers, 2 will usually come out. Okay, but in this case, I can also take out 4. I want to take out the largest number I can, so I divide both of these by 4. 64 divided by 4 is 16. 100 divided by 4 is 25. I can't reduce that one, so there's my answer. 9.675. Okay, the whole number, the number to the left of the decimal we leave. Okay, we're going to write this as a proper fraction, and I write 675 over what? 1,000, because the 5 is in the thousandths decimal place. So what you could do is, how many decimal places? There are 3, so that's how many zeros need to be underneath. Okay, then what we can reduce by, obviously 5, but I would go by 25. Okay, 675 divided by 25, I believe, is 27. Okay, and then 1,000 divided by 25 is 40. So there's my answer, 9 and 27 over 40. Any questions? Easy enough. All right, write these. This is when we were trying to write a repeating decimal as a fraction. Now remember, when it's repeating, it's going to be slightly different. Okay? I still write 6 on top. But since it's 6 repeating, I can't write it over 10. Because if I write 6 over 10, it's going to leave me a 0.6. I need 0.6 repeating. So instead what I do is I write a 9 for every number that's repeating. I have one number repeating, so I write it over 9. 6 divided by 9 gives me 0.6 repeating. Okay, I can reduce 6/9 into 2/3. 2/3, if you write that as a decimal, is 0.6 repeating.
So if you have
with 0.42 repeating, I'd write 42 on top. On bottom, I would write 99. A 9 for each number that's repeating. Okay? Now, there's the book explains it in a certain way that's kind of confusing and it's long. Okay? I'm teaching you guys a shortcut because I don't think it's important for you guys to need to know how to work it. Okay? The book gives harder examples that it's kind of important to know this, but I'm not making you do those. Okay? All I'm making you do is problems like this because I don't think it's really important for you to know all that stuff. All I want you to know is that if you see a number repeating, you write it over 9, okay, or 99. Or if you had a number like this, what would you write that over? 999, right? A 9 for each number repeating. If you don't believe me, put it in a calculator. It'll show you. Okay. All right, write this down. All right, so again, this is just stating what I want you to know, and that's just that any repeating decimal can be written as a fraction. So repeating decimals are also considered rational numbers. Because 0.36, like I said, we can write that as 36 over 99. Take 3 out of each of those and get 12 over 33. Okay, take 3 of that and get 4/11ths. Okay, that is a fraction. So I can still write these numbers as a fraction, so they're rational numbers. All right, write this down. Decimals that neither terminate nor repeat are what we call irrational numbers, which we'll talk about those more later on. Okay, but you need to know what they are. Irrational, they don't repeat, there's not a pattern. Okay, if you look here, it's not 78, 78, 78. It's 78, 778, 7778. Okay, there's not a repeating pattern there. Okay, so this is an irrational number. Pi is an irrational number because it is completely random. Okay, it does not end, and there's not a pattern to it. Okay, it goes to, they have calculators that go into millions of digits. Okay, so this is what we call an irrational number. All right, write these down. We're going to classify numbers. We have 1.3133133. Okay, 1. Okay, what is that?
Irrational.
That's going to be irrational. It doesn't have a certain pattern. Okay, and it doesn't end. So I'd write irrational. Okay, you can abbreviate. I'm fine with that. 45. What is it? It is a whole number. It is a natural number. It is an integer. Okay, it's also a rational number. About -2, 6 over 11. It's a rational number. Is it anything else? It is not an integer. Just because it's negative doesn't make it an integer. Integers don't have fractions or decimals behind it. They are whole numbers with negative signs. So -2, 6 over 11 is just rational. What about 0? 0 is rational. It can be written as fraction. Right? What else? It is not a natural number. Natural numbers are 1, 2, 3, and 4, but it is a whole number. It is also an integer. Good. All right, that's what you're going to do today. Any questions? Here's your homework.